Hello guys, in this video we'll be talking about using congruent triangles. So up until this point we have been only focused on proving whether or not two triangles are congruent. Well, now we're going to talk about what happens after that. So now the triangles are congruent, what can we do now? We have this acronym CPCTC. We've already gone over it beforehand. It stands for corresponding parts of congruent triangles are congruent. Now that we've proved triangles congruent, we can use that fact to prove the other pieces of the triangle are also congruent. This will add on to the proof as a last step, so it's an extra step to the end, and it'll make more sense as we do it. So in this PowerPoint, or in this video, we're going to go over and do 3 proofs. The first part of the proof will be proving the triangles are congruent. The last part of the proof will be using this acronym to show that the other parts of the triangle are also congruent. Right, and here's the first one. So, given that C is the midpoint of BD and AC is perpendicular to BD, we need to prove that BAC is congruent to DAC. So there's a lot going on in this picture. Let's start off with just annotating our triangle. So we are told that C is the midpoint of BD. So that means that BC is congruent to CD. We are also told that AC is perpendicular to BD, which means we can add that right there. Okay? Now what I'm going to do, that's the end of my given, but I'm going to look at the picture and see what other pieces of information can I get from it. And I see that I have a shared side here in the middle. So I know that AC is congruent to itself. Okay. Now that I'm done annotating everything I can, take a step back. As I'm looking at the picture, I notice that I have 2 triangles and I have my 3 pieces of information. I have a side, an angle, and a side, which means that these 2 triangles are congruent because of the side, angle, side postulate. Okay? I'm going to pause there and fill in my proof up until this point. That way we can keep going through the logic. So our first is the given. Don't forget your notation. This is our given. Next, we know that BC is congruent to DC. We've already marked that, and that is because of the definition of midpoints. Now our next step says that angle ACB and angle ACD are right angles. As we look at our picture, we know that. Both of these angles up here are right angles, and that is because of the definition of perpendicular lines. Because perpendicular lines creates right angles. Next, we have that the 2 angles are congruent. Well, we know that because all right angles are congruent. Yeah. So beforehand, we would go into saying that each angle is 90 degrees, and therefore they're congruent, or they're equal because their measures are equal. Now we can just go straight and say that all right angles are congruent. Okay. Finally, we have that AC is congruent to AC. And that is because of the reflexive property. Now remember, the reason why we're going through this is because we need to prove these 2 triangles are congruent. Because once we prove these 2 triangles are congruent, we can use the acronym CPCTC to prove these 2 pieces are congruent. So let's finish this off. We now know that triangle ACB is congruent to triangle ACD because of the side, angle, side postulate. And I know the triangle names are already written out, but again, pay attention. All of the corresponding angles match. In this name, all the angles, the corresponding angles, match to the corresponding angles of the other one. And that's important because this acronym is that corresponding parts of congruent triangles are congruent. So let's look at these two angles. Are these two angles corresponding pieces? We have, I'll do it in a different color. We have angle BAC, so that's up here, this angle. And we have DAC, which is also up here. Both of these angles are at the end of this second congruent marked line, so they're on top of the right angle. They're in the same place on both triangles, so yes, they are corresponding. Which means we can finish this off by saying that angle BAC is congruent to angle DAC because of corresponding parts of congruent triangles are congruent. Sign off, and you're done. Let's do it again with a different picture. Okay? If you want, pause the video now and see how far you can get. Otherwise, here we go. So we are told that PR bisects the angle QPS and the angle QRS. And we need to prove that PQ is congruent to PS. First things first, let's annotate our picture. So PR bisects QPS and, okay, right there, and QRS. And there we go. And that's all we have given. But as I look at my picture, I notice that PR is in these two different triangles. It's in both triangles, which means that it is congruent to itself. Now that I have annotated as far as I can, I take a step back. As I'm looking at this picture, I notice I have two triangles, and I have three pieces of information. I have an angle, a side, and an angle, which means that these two triangles are congruent because of the angle, side, angle postulate. Now I am trying to prove that PQ is congruent to PS. The next thing I have to do is figure out if these two pieces are corresponding. Because if they are, then we can use the acronym. And as I look at them, the answer is yes. They both come from the angle with the one congruency mark, and they go up to the non-marked angle. With that all being annotated, let's do our proof. PR bisects the angles. And this is our given. Now the first thing I'm going to do, since our given talks about a segment bisecting angles, is I'm going to mention that next in my proof. So I have angle QPR is congruent to angle SPR, and angle QRP, oops, it's a bad R, is congruent to angle SRP. And that is because of the definition of angle bisectors. Next thing I'm going to do is I'm going to mention my shared side. So PR, segment PR, is congruent to segment PR because of the reflexive property. And now I have all the information needed. I can say that triangle PQR is congruent to triangle PSR because of the angle, side, angle postulate. Again, make sure your angles match up. Corresponding angles need to match up. Now that I've proven that these two triangles are congruent, I can go to my last step and say that PQ, line segment PQ, is congruent to line segment PS because of corresponding parts of congruent triangles are congruent. If you did it on your own, check and see if you have all the information. As a bit of a side note, these two pieces of information can be flipped. So the order of these two doesn't matter, but both of them have to come before you say the triangles are congruent. So these two steps have to come first before you say the triangles are congruent. All right, last proof. What I want you to do is pause the video and do the whole thing yourself. See how far you can get and if you can do it correctly. Then come back and play the video and see if your answer matches mine. And let's go. So we are given that E is the midpoint of MJ and that segment TE is perpendicular to segment MJ. So let's annotate this. E is the midpoint. So these two pieces are congruent. And TE is perpendicular to MJ, which means that's a right angle, and this is a right angle. As I look at my picture, I notice that TE is in both triangles, so I'm going to mark that as congruent to itself. I now notice that I have a side, an angle, and a side, which means that these two triangles are going to be congruent because of the side, angle, side property, postulate. Okay. And that's actually what I'm trying to prove, so that would be the end of my proof right there. Let's go ahead and start. So here's my given. I'm going to do my definition of midpoint first. So segment ME is congruent to segment EJ. And this is because the definition of midpoint. Then I know that angle TEM and angle TEJ are right angles. And that's because of the definition of perpendicular lines. Then because those two are right angles, I know that they're congruent to each other. Because all right angles are congruent. And then last but not least, I know that TE is congruent to itself because of the reflexive property. Now I have all of my pieces. I have my side, I have my angle, and I have my side. So I can go ahead and go straight to my proof and say that triangle MET is congruent to triangle JET because of the side, angle, side postulate. Sign off, and we're done. Okay, hopefully you got close, if not exactly right. If you have any questions, be sure to ask them in class, and I'll see you next time.